Hi, grade 8. Let's take a look at a few questions on exponents. Very, very important. Now, the first thing I would like to do before I look at a few sums is to remind us of the laws of exponent. Laws of exponent. Very, very key. So I'm just going to put that here. Our laws. Number one, if I am multiplying two things with the same base. Remember, a is the base and m is the exponent. A is the base and n. If they are of the same, what do? We pick one of the bases and add. Keep the base and add. Number two, if we are divided, same base, we usually subtract where the exponent is bigger. So if my m is bigger than n, then I'll have a m minus n. This is if m is bigger than n. But what if the denominator exponent is bigger? What do we then have? N minus m. This is if n is bigger than m. We always subtract where it is more. Law number three, if we have an exponent to a power, what do? Here we multiply the exponent. And finally, number four, which is similar to number three, but we are going to have them having two in the bracket. What do? Oh, let's put a p here. What do? We distribute and multiply. So it's going to be a m times p times b and times p. This is very, very important. Now, a few other things that we need to remind ourselves of quickly is if I have a negative in the bracket and my exponent is even, my answer will be positive. If I have a positive in the bracket, if I have a negative in the bracket and my exponent is odd, my answer would be negative. So these are very important points. And finally, for now, anything to the power of 0 is 1. And it's important to quickly note all these laws, make sure you're able to see them because we are going to apply them. And please note, there's a difference between multiplication and addition and subtraction. We're going to see a few examples. So I've got a few questions for us. Number one, x to the power 2 multiplied by, we have exponent of 5. If you look at that, that looks like my law number 3. Oh, beautiful. I'm just going to multiply the exponent and I'm done. Number 2, so 2 times 5 is 10. Number 2, x to the power 3, y to the power 2, and I have a 3 power there. What do? I multiply my powers. So what would I have? X to be 3 times 3 multiplied by y. So I'm multiplying the power outside. And what do I have? X to the power 9 times y to the power 6. Number 3. Negative 2, x to the power 3, y to the power 2, everything to the power 3. Now, don't forget there is an invisible exponent under 2, which is 1. So I will be multiplying all my numbers, exponents, with the exponent outside. And remember, we said if it is negative in the bracket and an odd number, then our answer would be what? A negative. So I'm going to start with the sign and put the negative there. Now, 1 times 3, I'm just going to write it for clarity, times x, 3 times 3 times y, 2 times 3. So I am taking my exponent that is outside and multiplying with the exponent that is inside. Now our negative remains. Now 2 to the power 3, don't forget it is 2 times 2 times 2. That gives me 8. And then I have x to the power 9 and y to the power 6. And that question is done. Look at number 4. Negative 2x to the power 3, y to the power 2, and I have a 4. Now, in this case, please take note, my negative is outside, so it is not affected by this exponent in any way. So what are we going to have? My negative would remain. Now, what do I have? Remember, there's an invisible 1 there, which is 1 times 4 there, 3 times 4 there, and 2 times 4 there. What will that then give us? Now, this is 2 times 2 times 2 times 2, which is 16. Now, x to the power 12 and y to the power 8. I hope that makes sense. So you've got to repeat all of this and do as many questions using the same principle. Okay, let's go to, we have about 12 questions or so, and we're running out of time already. Number 5. What do we have? 5xy. Okay, I see now that this is addition and subtraction. So the first thing we said is we only, okay, let me do this quickly. When it comes to addition, just gonna drop this. Okay. When it comes to addition and subtraction, 2 minutes revision. We only add and subtract like terms. Emphasis on like terms. What do I mean by like terms? For things to be like terms, they must have two things. They must have the same variable and they must have the same exponent. So the idea is always arrange alphabetically. Arrange alphabetically and compare. And lastly, do not add or subtract exponents. Do not add or subtract exponents. For example, a to the power 2 plus a to the power 2. They are like terms because it's a to the power 2. So I'm going to start with my like term, a to the power 2. Now we know that there's a 1 there and there's a 1 there. So what is 1 plus 1? 2. You see, I didn't add my exponent of 2 and 2. No. I just keep my like terms. For example, 5x to the power 3 minus 6x to the power 3. Are they like terms? Yes. So what do? I write my like term first. Then I look at the integers. 5 minus 6 is negative 1. And mathematically, we don't need to put the 1. And that's just the basic rule. Write your like terms first. So let's look at this question quickly. Number 5. First, arrange alphabetically. 5xy plus 6y xy squared minus 8xy. All right. Do we have like terms? Yes. Which ones are like terms? I'm going to use colors, x and y. The number goes with the sign. Then you have xy squared and xy squared. So if I pick the green ones, what do I have? 5xy minus 8xy plus 6xy squared. Beautiful. 6xy squared. Now, if you look at the first two, what do you notice? They are like terms. And what's common? What's the like term? xy. So I'm going to start by saying xy. Then I'll look at the integer. 5 minus 8 will be negative 3. Now, if you look at this one, what do you notice? xy squared, but it is positive 6 minus 6. And that would give me a 0. So I don't need to put anything there, okay? Let's do this. If I look at what's common, xy squared, but 6 minus 6 is 0. And this is as equal to 0. So my answer will be that. If it's a 0, then I don't need to put it. Okay. Now let's look at number 6 from the activity that we have. Number 6. 4x to the power 2 all squared minus 4x squared plus 3x to the power 4 plus 2x to the power 2. Let's simplify. Remember, there's an invisible one there, and we multiply that. So that is 4 to the power 2, x to the power 4, minus, there's nothing to do there. There's nothing to do there. Don't forget, there's a 1 there. So 1 times 2 would give us 2. There's also a 1 there. X to the power 2. And we are now just going to simplify. 4 to the power 2 will be what? 16. So what is our 4 to the power 2? 16x to the power 4 minus 4x to the power 2 plus 3x to the power 2 plus 4x to the power 2. Which ones? Oh, this is 3x to the power 4. Sorry. So which ones are like terms? That and that. So if I write my like term out, x to the power 4. Now the numbers, positive 16, don't forget, plus 3 would give me positive 19. Now, negative 4x squared plus 4x squared. Do you notice that they are of the same value but opposite what? Signs. So, where is my, yep. So if I look at this, negative 4, positive 4, that would give me a 0, and we are done. Number 7. 8a to the power 2, b to the power 6. Now we go back to our division. Okay, let's look at the numbers. 8 and 16. 8 and 16. I think we can divide both the numerator, and we are not subtracting, please. We are, when it comes to the numbers, we are simply saying, is there something we can divide them with? Yes. 8 can divide 8, 1, and 8 can divide 16, 2. Okay, so I already see my answer, 1 over 2 there. Now we are subtracting, but where do we have more exponent? You see, a to the power 2, a to the power 3. I have more exponents at the bottom, so my answer should be at the bottom. And it's a to the power 1. Where did I get my 1 from? 3 minus 2. What about the b? We have more b's on top. It's b to the power 6. So my answer should be on top. 6 minus 4 would give me 2. So I can write this as b to the power 2 because 1 times b would still be b. So that's my answer. Number 8. 4x to the power 2, y to the power 3 over 2x to the power 2, y to the power 3. Again, I quickly check the numbers. 2 can divide 2, 1. 2 can divide 4. We have that. So already I have a 2 over 1. But now, do you notice this is x to the power 2 and x to the power 2? They are the same. So I can just cancel that and put 1, 1. Same to y to the power 3. Oh, similar stuff. So if you look at your answer, it's 2 times 1 times 1 over 1 times 1 times 1, and your answer simply is a 2. Number 9. Negative 4 x to the power 2, a to the power 5 over negative 8, a to the power 7, y to the power 2, and x to the power 2. Beautiful. Beautiful. I love this question. Let's look at the signs. Negative divided by negative would give me a positive. Then I'm looking at the numbers. 4 can divide 4, 1, and 4 can go in 8, 2. So already I have a 2 at the bottom. Now let's look at the a's. Check. I've got a to the power 7 and a to the power 5. Where do I have more a's? At the bottom. So what do I have? I have a to the power 2. Let's look at the x. It's x to the power 2 and x to the power 2, so that's fine. Do I have any y? Nope. So I just write my y. Nothing happens to the y. But I cannot leave my numerator empty, remember. So my 1, because 1 times 1 would give me 1. Number 10. Number 10. Negative 2x squared y cubed everything to the power 3 over 20 x to the power 7 y to the power 5. Now I am going to just go straight. It's a negative in the bracket and an odd number, so it's the negative. Now what do we have? Don't forget, it's 2 times 2 times 2, and that will give me 8, not 2 times 3. 2 times 2 times 2. Remember, I am now distributing. So x 2 times 3 would be 6, y 3 times 3 would be 9, over 20 x to the power 7. Let's start with the signs. There's a positive here, remember? So negative divided by positive would be negative. Now if you look at 8 and 20, we can divide both numbers by 4. 4 would go in 8, 2, and 4 would go in 25. So I have already seen my numbers. And what do I have? I have a 2 on top. Let's get a white pen. And a 5 at the bottom. Now let's check the x's. Where do we have more x? At the bottom. Oh, 7 minus 6 would be 1. So all I need to do is to write x to the power 1. And then where do I have more y's? At the top. 9 minus 5 would give me y to the power 4. Number 11. 5y to the power 4, y to the power 2, everything to the power 0. Once I see a power 0, I don't need to do much work. My answer is 1. Number 12, 8x to the power 0, y to the power 3, times 4x to the power 2, and y to the power 8. Remember, x to the power 0 is 1, so 8 times 1 is 8, and then I have, oh, okay, let's do this. Let's multiply the numbers first. All right, 8 times 4 will be what? 32. Now that I'm seeing this x and this x multiplication, I need to add rule number 1. So what is 0 plus 2? X to the power 2. And what is y? 3 plus 8. Okay, done. I hope that makes sense. Rule number 1. Number 13, x plus x times x. Oh, we're bringing our rule of BODMAS. Multiplication first, so we do that. So what would this be? X plus x, that will be x times x will be what? Times x to the power 2. Now what do we have here? Rule of BODMAS again, right? Rule of BODMAS. Look at that. Multiplication. X plus, this is to the power 1, x to the power 3. Are they like terms? No. So that's our final answer. And lastly, 3x cubed times 4x times x squared. Let's check. It's all multiplication, so we don't do like terms here. Let's look at the numbers. 3 times 4 would give us a 12. What about x? Remember there's a 1 here. So 3 plus 1 will give me 4 plus 2. So whenever we multiply, we add the exponents. I hope this little quick activities will just be sufficient to carry you on in terms of practicing more questions. All right, this is Crazy Physics, quickly helping your grade 8 to come up with revision. Goodbye, everybody, and like, subscribe, and share. Goodbye.